Sorry, my video stopped recording, so I had to delete some storage. But doing problem 3 from chapter 8, Greenberg Physics C. Here was the problem. It's a bead going through a system, this loop-to-loop. It's frictionless, and essentially what it's asking is the bead speed at point A, and then the normal force of the bead. So do my picture. And then, so we're going to solve for A first. So energy initial equals energy final according to the law of conservation of energy. And there's no friction. So its initial energy is mgh because it's up here. It's not moving. And then its final energy is, it has still potential energy because it's up here. But it's also moving, so it's kinetic energy. So mgh equals mgh plus half mv squared. The m's cancel out. Plugged in gravity and height. And then I plugged in half v squared, we're solving for velocity. So simplify that down, you get 34.3 r, which is radius, 90.6 r plus half v squared, and then you end up with velocity equals 5.42 square root r meters per second. Oh, that's sloppy, I'm sorry. I'm trying to think. That's your velocity. Okay, so using conservation of energy, we were able to solve for the velocity of the bead at point A. So now, for part B, we're going to use some of the forces to calculate for the normal force. So, let's do a free body diagram. That's your bead at point A. Normal force goes down, and mg goes down, which is the weight. And then, so then what we do is here equals normal force plus mg equals, since it's a circle, mv squared over r. And we're solving for normal force, so normal force equals mv squared over r minus mg. From there, we can just plug in. So they give us the mass, 5 grams, which is equal to 0.005 kilograms, times velocity, which is 5.42 square root of r. Since it's being squared, it's actually 29.3 r, because it's being squared, all over the radius, which is r, minus 0.005 kilograms at 9.8 meters per second squared. Cool. And then solving all that down, r's cancel out, multiply these and subtract from there. You end up with 0.098 newtons.